Part A has two parts. We are asked to find the mean number of fish caught by a contestant and the standard deviation. Okay, so we have a table of data here that represents the number of fish caught by each contestant out of 100 contestants in a fishing competition. So for example, 2 of the contestants didn't have a very good day and they caught 0 fish. In the middle here, there was 23 contestants that caught 4 fish, and on the upper end, there were 4 contestants that caught 8 fish. So just looking at our data here, we can see that the majority of contestants, the 3, 4, 5, 6 mark, you can see it's sort of clustered here in the middle. So you would expect that the mean would be around the 4 or 5. And as for the standard deviation is a measure of the spread of data. Is it really spread out or is it clustered around the middle? And the lower the number, it means that it's clustered near the mean. And I would say that it's pretty clustered. You can see here 14 people caught 3, 23 people caught 4, 20 caught 5, etc. Whereas it sort of tails away at the extremes. Only 2 people caught 0 and only 4 caught 8. So I would expect a fairly small standard deviation and I would expect a mean around the 4 or 5 mark. But let's go ahead and use our calculator to find these 2 items. Okay, we bring the calculator up. We go to the statistics section, this green icon here. Okay, I'm going to enter my data in. I'm going to enter it into 2 columns. Even though my table here has 2 rows and many columns, when we enter data into our calculator, we enter it downwards. So 2 columns, many rows. First things first, let's label our columns such that in the next step, when we perform the one variable statistic calculation, we can pull the column through that we're interested. So this one here is number of fish. Got to be careful here. I usually call the frequency column F, which I'll continue to do. So I've got to be careful not using F for fish here, but I'll call it N for number of fish. Okay, let's go ahead and enter this. I'll just enter the first U, then I'll pause the video and enter the remaining so I don't waste your time. So I'm entering down this first column here. So this is number of fish. This is this first row here. So 0, 1, 2, and so on and so on. And the frequency will be the bottom row. So this will be 2, 5, 9. Now I'll go ahead and enter the rest. Okay, so there we have it. We have finished the data entry. Let's now go up to the top of the next available column and perform a one variable statistic calculation. It's only one variable because there is only one variable here in my table. It's only the number of fish caught. If it was 2 variable, it might be number of fish caught and maybe the wind speed or maybe the tides or maybe the temperature, some other variable that may affect the number of fish caught. But we don't have this. This is a one variable statistic question. So we're going to go menu, number 4, statistics, number 1, stat calculations, and number 1, one variable statistics. Number of lists we just leave as 1. Okay, the X1 list, this is the first column. So I labeled that as N for number of fish. I'll select N. The frequency list is F for frequency. Hit OK, and we get some good information here. So looking at the solution here, our mean is this X bar, and that's 4.35. So I was pretty close with my guess. The average number of fish caught by a contestant is around that 4 or 5 mark. Well, more accurately, it is 4.35. And the standard deviation, now we need to be careful that we select the right one here. SX stands for sample standard deviation. However, my interpretation of this question is that these 100 contestants weren't a sample. It actually was the entire population. They were all the contestants. So therefore, we're actually going to use sigma x, which stands for population standard deviation, which is the whole group, not taking a sample of the group. You can see they're pretty close numbers there, but we'll use this one to be precise. So 1.82. Okay, they are the 2 answers to part A. Part B asks to find the median number of fish caught in the contest. Now notice here that this question part is only worth 1 mark. If it's only worth 1 mark, it's usually a bit of a signal that this can be found fairly easily and fairly quickly. And even though I look like I have a lot of working here, you can actually find it from the calculator stat calculation that we performed back in part A straight away. So I'll firstly show that, and then I'll talk about the by hand method, because I think it's also good to know how to do this by hand as well, and it teaches you some skills in terms of cumulative frequency and grouping, etc. But let's bring the calculator up. This was the screen that I had at the end of part A. So if you're not sure how I got this screen, I recommend going back and watching part A. If I go down, you can see here median. Actually, the calculator one variable stat calculation actually gives me the median and also the lower and upper quartile, which is going to be useful for part C. But the median here, the calculator said is 4. So there we have it. It's only worth 1 mark. You can use your calculator. So you can just write median is 4. And that's the answer there. But looking at this by hand method here, let's just firstly recap on what the median actually is, the definition of the median. If you lined up all of these contestants from the least number of fish, which are these 2 people that caught 0, all the way to the most number of fish caught, which are these 4 contestants that caught 8, so there'd be 100 contestants standing in front of you, and you selected the middle contestant. Now, for an even number of contestants, which is what we have, which is 100, it'll actually be between 2 people. In this case here, it'll actually be between the 50th and between the 51st, and then we just average those 2 people, the 50th and the 51st. So if you pick that point in between the 50th and in between the 51st, and you took the average of the amount of fish that they both caught, that would be your median. So the way that I did this here, I added a cumulative frequency column to my table. The way that we work these numbers out, it's always just the sum of all the previous frequencies, including that particular frequency. So for example, this 16 here is just simply the sum of these 3 frequencies. Likewise, this 53 will just be the sum of all of these frequencies. And a shortcut way to do it is just the previous cumulative frequency plus the next frequency is equal to the cumulative frequency number that you're looking for. And then this grouping column is just to be able to easily see, okay, where is the 50th person? Well, the 50th person would be in this row here, because this row here includes all the people, all the contestants from the 31st person all the way up to the 53rd person. So this row here actually includes both the 50th and the 51st person. Now this row, all these contestants caught 4 fish, so therefore we can say our median number of fish caught is 4. And that lines up with our calculator output that we got earlier. Part C asks to find the interquartile range. Now, similar to Part B, we can actually find this pretty quickly and easily using the calculator stat calculation that we found in Part A. So if I bring the calculator screen up, in Part A, I found all this useful information here. So if you're not sure how I got the screen, I recommend going back and watching Part A. But in this screen here, we actually are given the lower quartile, which is 3, and the upper quartile, which is 6. So when we have those 2 pieces of information, finding the interquartile range is pretty straightforward, because the interquartile range is just simply Q3, the upper quartile, subtract Q1, which is the lower quartile. So 6 take 3 is 3. Now, what does this number here mean, the interquartile range? If you were to line all 100 contestants up from least amount of fish caught to most amount of fish caught, so that would be the first 2 people standing in front of you would have caught 0 fish, and the last 4 people would have caught 8 fish, and you find the 75th person, which would be the upper quartile, and the 25th person, which would be the lower quartile. Roughly speaking, the actual exact numbers there are slightly off, 25.25 and 75.75, but I'll stay pretty high level for this description. The range in fish caught between that middle 50 people, so from the 25th person to the 75th person, that represents the middle 50% of contestants, that range in fish caught would be 3 fish. And that's what we call the interquartile range, the middle 50% of the data. So we have it there. I do have a by hand method here, which builds off the cumulative frequency table here that I built in Part B. So just quickly covering that, the proper definition for the lower quartile is a quarter times the number of data points that we have, which is 100 plus 1, so 25.25. So between the 25th and the 26th person. The upper quartile is between the 75th and the 76th person. We then cross-check that against our table here. So between the 25th and 26th, that would be in this row here, because this row here encapsulates from the 17th person all the way up to the 30th, and they caught 3 fish. And between the 75th and the 76th person is this row here, and they all caught 6 fish. So there we have it, Q3 is 6 and Q1 is 3, and that gives us our interquartile range of 3 fish. Part D, determine if a contestant who caught 10 fish, so he had a good day out, he caught many fish, he would be over here. So I'd have one more contestant here that caught 10 fish. He's clearly the winner in this fishing contest, assuming that the winner is determined by most number of fish, not say biggest fish. But let's continue on. Determine if a contestant who caught 10 fish would be considered an outlier. Now, this new contestant kind of does look like they are an outlier because it's quite a lot. This data point here is quite high in comparison to all the other ones. We found in part A that the mean was 4.35 and quite a low standard deviation in terms of the contestants were clustered around the mean. But we do now have a formal definition of what an outlier is. So let's have a look at this definition, and then we can determine whether a contestant who caught 10 fish would be considered an outlier. Now, the definition is for an upper data value, so higher than, say, the mean, the definition is if the data point is within the upper quartile plus 1.5 times the interquartile range, if the new data point is still within that number, then it is not considered an outlier. And likewise on the minimum end, if the data point is more than or within the boundary of the lower quartile subtract 1.5 times the interquartile range, then it would not be considered an outlier. So we're interested in the upper end because this contestant caught a lot of fish, much higher than the mean and the upper quartile. So let's test this here. It's the upper quartile, Q3, which we found back in part C to be 6. So 6 plus 1.5 times interquartile range, which we also found in part C to be 3, and that is 10.5. So although this new data point seemed high, it is actually still within this interval. It is within the interval from negative 1.5 to 10.5, and any new data point that is within this interval would not be considered an outlier. So there we have it. That is the answer to part D. Part E, we are told that one of these 100 contestants is chosen at random. So if we were to line them all up and then randomly choose one person, find the probability that this chosen contestant caught 6 fish or more. So looking at the table here, I'm interested in these people here to the right here that caught 6 fish, so 6 or more, so 6, 7 or 8. So that's these 15 contestants here, these 8 contestants here, and these 4 contestants here. So pretty simple probability question here. We're looking at if we were to look at all 100 contestants, randomly chose a contestant, what is the probability that they were either these 15, 8 or 4? So looking at the solution. So I've said here, let C1 be the number of fish caught by the first contestant. The reason I've called this C1 is in later parts, we actually have a second contestant, which I've defined as C2. So if you're a little bit confused where C1 came from, that's contestant 1. So we have the probability of contestant 1 catching at least 6 or more would be these 15 people that caught 6, the 8 people that caught 7, and the 4 people that caught 8, I think it is. Let's just check that. Yes, 8. All divided by the total number of contestants, which is 100, and that gets, let's just check that in the calculator. So it is, let's set up a fraction. It is 15 plus 8 plus 4, all divided by 100, and that is 27 on 100, which is 0.27. So about 27% chance that by choosing one person out of the 100, you'll select someone who caught 6 fish or more. So not a great probability, but also a decent 27% chance. Somewhat likely. If you pick 4 people out of those 4, you'd probably have one that caught 6 or more. But okay, that is the answer to part E. Part F, we are told now that a second contestant is chosen at random. So this is after the first contestant. And we are asked, and this is a bit of a challenging conditional probability question here. Given, that's always a bit of a hint that this is a conditional probability question. So given that the first contestant caught 6 fish or more, find the probability that each of these 2 contestants caught exactly 7 fish. Now keep in mind here that given the first contestant caught 6 fish or more, that's actually the probability that we did find in part E. So just keep that in mind. Okay, so given that the first contestant caught 6 fish or more, find the probability that each of the first 2 contestants caught exactly 7 fish. Let's have a look at the solution here. I'm just going to go across because I have the conditional probability formula. Let's just touch on this conditional probability formula here. So probability of A given B, that's what this vertical line here means. It means given. So probability of A given B will be equal to the probability of A and B occurring divided by the probability of the second letter here, B. So keep in mind that we had the given the first contestant caught 6 fish or more. So the denominator is just simply going to be the probability that we found back in part E, which is 0.27. So that's where the denominator comes from. But let's have a look at the numerator here. The probability that both contestants caught 7 fish exactly. So that's here. Now the numerator, this is a bit of a sort of conceptual understanding here. The probability of both contestant 1 and contestant 2 catching 7 and them both catching more than 6, well, in order for them to both catch 7, they would have therefore caught more than 6. So this numerator is just simply can be summarized as just the probability of both of them catching 7. Because if they both catch 7, well, of course they're going to catch more than 6. They need to catch more than 6 in order to catch 7. So I have summarized the numerator here as the probability of contestant 1 catching 7 exactly, and then contestant 2 catching 7 exactly. And then we can visualize this as a tree diagram. So contestant 1, so catching 7, not 7, and then contestant 2 catching 7 and not 7. Now keep in mind that this is probability, multi-stage probability. So contestant 1, contestant 2 without replacement, because the first contestant isn't going back into the group of 100 people. So this here, this first probability will be out of 100 people, but the second will be out of 99 people because the first person has been taken out. Now let's just check how many people caught 7. There were 8 contestants that caught 7 fish. So the first contestant will have a probability of 8 out of 100. And then once that person has been taken away, there will be 7 contestants left that caught 7. So it's going to be 7 out of 99. So, and when you have a multi-stage probability event, you multiply up the branches. So that's where this numerator here comes from. 8 on 100, which is the first contestant, multiplied by 7 on 99, which is the second contestant. And then we do that division. And let's just check this on our calculator, just to make sure it's correct. Okay, let's set up a fraction. It's going to be a fraction on a fraction. Actually, I'll just do a division inside that. So this will be 8 on 100 multiplied by 7 on 99, all divided by 0.27, and we get 0.021. Okay, that is the answer to part F. Part G has 2 parts, and we now move into normal distribution type questions here. So we are told that the cost of the fishing equipment used by the 100 contestants is normally distributed with a mean of $1,200 US, expensive fishing equipment, and a standard deviation of 300 USD. So you can see that I have summarized that here in this normal distribution curve here. So we have a mean, the center line here at 1200, and each standard deviation line is 300 above and below the mean, so 1500 and 900, and then 2 standard deviations will be 1800 and 600. Okay, part 1 of part G says calculate the probability that a contestant chosen at random spent at least $1,000 US on the fishing equipment. So that is represented in the shaded region here. So there's all of this shaded region here is spending over $1,000. So you can see it's going to be more than 50%, because the way that a normal distribution curve works is you have 50% of the data above the mean, so to the right of this line here, and 50% of the data, or in other words, 50% of the area to the left-hand side of this mean center line as well. So if you were to try to sort of estimate, okay, well, if all the area under this curve here is equal to 1, or 100 as a percentage, then what area would the shaded region be? And looking at that, I'd probably say, about 70%, maybe 75%, maybe 80%. It's not going to be probably 90%, but it's also not going to be 50%. So that's probably an estimate. And how that relates to this actual question here is, if we represent the cost of fishing equipment for all contestants as area under this curve here, then if I estimated this as 70%, that means the probability of selecting a contestant who spent more than $1,000 would be about 70%, or 0.7 as a decimal. But we can find the exact value of the shaded area using the normal distribution command in our calculator called normal CDF. So let's go ahead and do that. Okay, we go menu, number 5, probability, number 5 again, distributions. And for normal distribution questions, we either use number 2, normal CDF, which is when we want to find the area of a shaded region, so the area under a curve, or we use inverse normal, which is when we have the area and we want to find the value on the horizontal axis. But for this question, we want to find the area, so we're going to use normal CDF. Okay, the lower bound is going to be the left value. So in our case here, we're looking at contestants that paid more than 1,000. So the lower bound on the horizontal axis here, the left-hand side of the shaded region is 1,000. The upper bound, we don't actually know. I could use, say, 2,100, but it's always safe to just use a really, really big value. Or if the shaded region was, we weren't sure on the minimum side, a really, really small value, like, for example, 0, because you can't really buy fishing equipment for less than 0. So I'm just going to put a really big value in here. I just chose 10,000 because I think that would probably include the maximum amount that any contestant could spend on their fishing equipment. I mean, you could even put 1 million in here. As long as you choose a really big number, the end result will be the same, the end answer. Okay, the mean is 1,200. And the standard deviation is 300. And we hit enter, and there we have it there. So my estimate was pretty correct. Rounding to 3 significant figures will be 0.748. So as a probability, the probability of selecting a contestant that spent over $1,000 would be 0.748, or as a percentage, 74.8%. Now the follow-on question, which is the second part of G, asks you to calculate the expected number of contestants that spent at least $1,000 on the fishing equipment. Now we found the probability that a randomly chosen selected would spend over 1,000, and that is 0.748. And we also know that there were 100 contestants. So to find out what the expected number of contestants out of the 100 that spent 1,000 will be the total number of contestants, 100, multiplied by the probability that we are interested in, which is this value here, 0.748. And if we do that multiplication, we get 74.8. So what does this number mean? It means that of the 100 contestants that we have in front of us here, what is the expected number of that 100 who spent more than 1,000 on their fishing equipment? It would be 74.8 contestants.